Hello, we are going to discuss a Spotify recommendation system and deploying that recommendation system in a web app on Streamlit. The playlist I am using can be obtained by through Spotify. It is a Python library that lets you access the Spotify API. And using that, we can put in the username and the playlist URI of the playlist we're looking to get our metadata and audio features and save it as a CSV file. And in this case, the file we have is over 1,700 tracks. We can cluster our data by using its audio features. And I'll explain this more in a little bit, but some of them are danceability, energy, acousticness, kind of visualizing all of these features on a 2D space and using a process called k-means to find the optimal number of clusters where we can view our songs. And in this case, it's 3 clusters. We could also visualize as 2 clusters, which is similar data points to what we just used in order to predict which song can be put into which cluster. With this model, using a technique called gradient boosting, we were able to get 96.8% accuracy on a test set when in predicting which song will fit where on our axis here. But more importantly, we can see which features, which audio features were the most important in this prediction. We have energy, acousticness, and danceability. These are at the top, especially energy. And some of the ones, instrumentalness, liveness, not as important in this modeling. We can also look in the visualization on the right. This is a sample track, and you can see which features had a certain amount of effect on where the track ended up in our 2D space. And you can see with this particular track, acousticness is pretty high, energy and instrumentalness up there too. So knowing this, we can kind of build a recommendation system that kind of takes this into account and uses it when we're looking to select songs to show to our user. This is going to be a content-based recommendation system. We have our songs on our 2D space. We can use Spotify to get our song info. Using scale data, we're going to calculate a mean vector of these features and use a cosine distance to get our closest songs. And that's what we're going to return to our user. And the way we're going to do this is in an app we build on Streamlit. For this purpose, we're going to use a playlist from Fortet, electronic DJ and producer. We're going to want a sidebar so we can look at our audio features and a way to text input our songs and listen to the songs in the browser. So let's go to the app here. And we're going to see here at the top of our Streamlit app that is loading. Okay, we have our sidebar with audio features. We'll get to that in a second. We have our playlist from Fortet here. You can listen to any of these songs, get a sense of how the playlist works. You can fill in up to 3 songs, and start by just in one, and that'll be a Herbie Hancock track. We hit go here, and the recommendation system is going to return tracks to listen to, and you can listen to these in your browser and see kind of how they compare to the song you inputted. And you can input up to 3 songs, so let's input Flashlight by Parliament, and then a more classical track in C by Terry Riley. And these are kind of 3 different songs, so it's going to be interesting to see what the recommendation system gives you. This playlist has more hip hop, dance, R&B, and jazz. So these are kind of the songs that the types of songs you might want to select to input here in the recommendation system. Now, if we look at the sidebar on the left, it has a number of audio features, and I've included descriptions of these on the bottom here. We're going to just reload this for a moment, and we're going to use the sidebar to adjust the audio features manually. Instead of a manual input of a song, we're going to scale these, and let's pick a track that's a little low dance, low energy, high acousticness, maybe a medium level of instrumentalness. Don't worry about liveness, maybe a medium level of loudness, a low speechiness, kind of a medium tempo, and a low to medium size valence. And you can see kind of the tracks that show up, and you can listen to these in the browser to see how well they correlate to your selections here. But it's very interesting to keep changing these, especially knowing that we know about energy, acousticness, these features affecting our results greatly. This can be changed, and the results will change based on that. And so that's our recommendation system. Now, this seems like it's of best use for kind of more genre niche playlists. Fortet has his own audience, 1,700 songs. And for creators especially, selecting their own songs and developing a way for users to kind of have access to their tracks based on songs that a user might like. This could be used in conjunction with Spotify's own model, using collaborative filtering based on similar artists, similar tracks that Spotify already uses. And we could focus better on the Spotify Streamlit process, especially with our UI UX, maybe a process in-app where a user can input the tracks in the Spotify app on the desktop or on the iOS app, anything like that, and get the tracks delivered to them kind of in a more seamless manner. Thank you very much.